In this lesson, we will look at F5 application delivery platform and different optimization methods. First of all, F5 can be deployed in multiple ways, like the virtual edition, Viprion, and the hardware appliance. The virtualized edition is a virtualized image of the F5 application delivery controller, so you will download F5 Big IP software that support many modules like Local Traffic Manager, Access Policy Manager, and more. Then you get a license and deploy the virtual image on a virtual environment like VMware. It provides a lot of flexibility. You can decide what modules to provision or enable. For example, if you want this Big IP to run only LTM or LTM with ASM and so on. But you need to have the required amount of resources like CPU and memory. It also has flexible, quick deployment and failure isolation, so deploying the virtual edition is not very complicated. And it also has the flexibility to run in cloud environments like Amazon Web Services or AWS. On the other hand, we have the F5 appliance, which consists of a physical hardware device that runs F5 software. In the virtual edition, we have an image that's installed on a server. But with F5 appliance, we have a ready physical device that can be plugged into the network, so there is no need to install any virtual images. Also, using the physical platform provides better performance because it's running on a physical device that is purposely built for application delivery. Next, using F5 physical platform offers a single vendor solution, meaning that you won't have to deal with multiple parties if there is an issue. For example, if a customer is running F5 Virtual Edition on top of VMware on a Dell or HP server and an issue arises, troubleshooting between vendors is more difficult because you have to check multiple things and there are different people responsible for those things. For example, it might be a problem in F5 image or the configuration, so you have to call the people who are responsible for F5 configuration. The issue might also be on VMware or the server running the virtual image, so you have to have the people responsible for that too. But when using the F5 appliance, both your hardware and software are from the same vendor, so you can call them to come and fix it for you since everything came from them and they know how to make it work. Also, F5 physical device can run all Big IP modules and have special chips to perform hardware SSL offloading and compression with better performance. When it comes to the challenges, Virtual Edition doesn't have SSL or compression hardware offloading, and it uses greater CPU resources, which may affect the performance. Also, the hardware is not supported by the software vendor. Now, the challenge with the physical appliance is that it costs more money and it lacks flexibility except for Viprion, which can be added to. But hardware appliances in general don't scale. If you need to do more than your current device have capacity for, you have to replace it with a larger device. Implementing it also takes more time because you have to buy it, and the hardware delivery may take from 4 to 8 weeks or more, plus the hardware provisioning. And lastly, some public cloud environments do not let you run your own hardware since it is a strictly virtualized environment, so in that case you have to use a virtual image. Even on private cloud deployments, the virtual edition is recommended because of its flexibility. Next, we have HTTP pipelining, which relies on persistent connections or HTTP keep alives. It is used to make performance better, especially over high latency connections where waiting for a response before sending the next request can cause a lot of delays. HTTP pipelining will send multiple requests that come after each other over the same persistent connection without waiting for the response from the server. This will avoid the latency of the connection, and performance could also be improved. Now, to look at how connection keep alives work without HTTP pipelining, we have a client and a web server. And when the communication starts, first of all, we have the TCP three-way handshake. And when the TCP session starts, then the request will be sent to the server with a connection set to keep alive, so the TCP connection doesn't close after this request. The web server will process and send a response back to the client, and the client will be waiting and not sending the next request until it receives a response. So when the response is received, it starts sending the next request. The connection is still set to keep alive, and then the server processes again and finishes its processing and send the response back, waits again for the client to send the third request with the connection sent to close, which means that this is the last request. And when this is processed, the server will again send the response to the client. And here we can see that the web server, each time it finishes processing a request, it just sits and waits while the response is being sent back to the client, and while the client makes the new request and send it again to the server. To reduce this passive time of the web server, with HTTP pipelining, the first request will be sent with the connection set to keep alive. The next request will be sent. All of these three requests are in the same persistent connection, so they are all sent at the same time. So the server now is going to process all three requests and then send the responses all together to the client. So now the server doesn't have to be idle and wait for the response to be sent back to the client and then wait for another request to come. All the requests in one persistent connection are going to be sent one time, and all the responses are going to be sent one time. We also have HTTP cache, which is performed to increase performance, and it also another form of server offloading. Caching can be done as client-side caching with the client's browser, like Chrome or Firefox. Response content is stored in the browser's local cache. Then when there are new requests for the same content, the cache content is used and displayed, and this will reduce the need to request it from the server again. F5 caching is considered server-side cache, and the server offloading is the primary focus. So here we have the client, the web server, and the big IP in the middle. In this example, first the client will request a web page. The big IP will receive this request and then send it to the web server. The web server will send the response back to the big IP. The big IP will cache the content of this response. For example, if it's an image, it will cache this image and then send back the response to the client. And the next time the client or any other client tries to request the same content again, the big IP will not ask the server for it because it already have the content cached, and it will just send the response back to the user without involving the web server. There is also file compression, which have the purpose of reducing the size of files sent by a web server, and this is done by eliminating repeated information in those files, because the smaller the size of the files, the more quickly they can be served over the internet. For example, here again we have the same diagram. A client will request a file or a web page from a server. If the client supports compression, it will use the accept encoding parameter in the HTTP GET request. The request gets to the big IP, then the big IP will send it to the web server. The web server will send an uncompressed response to the big IP. Let's say the size was 200. Then the big IP will receive and compress the file, then send a 40 compressed file back to the client. So now the size of this file have decreased. When the client receives the compressed file, they can uncompress it to get it back to its original form.